Okay, good evening. Good evening, my friends. My name is Davide Arnoldi. I have a second name also, is Enrico, but anyway, you can call me Davide Arnoldi. It's okay. Welcome on board. Enjoy this webinar for functional safety. And then we are a lot of people today, more than 60, 68, but it continues to grow up. And this is very pleasure for me. This means that probably functional safety is required. So the people want to learn about functional safety. And then today, we have, I'm reading also your chat, your message. Unfortunately, I don't know very well location of Ankara because I was in Istanbul 2 years ago before COVID. And I'm CEO of Mind. That mind is a contraction of my mind. The meaning of mind is I'm here to develop your skill about functional safety. And this functional safety is the matter, very important matter for the engineering. I'm here with the invitation by the Chamber of Electrical Engineer of Ankara that I love to thank you to all engineers for this fantastic group. And today I would like to speak with you about the functional safety, of course, that is my work, and to make an introduction. Unfortunately, functional safety is a very huge matter. Maybe it's required more than 1 week to speak entirely of the functional safety. But anyway, today we spend 1 hour and a half, 1 hour, 1 hour and a half in order to put some order in our mind related of some terms and misunderstanding about functional safety. Functional safety exists for different fields. One important field of functional safety, for example, is the automotive. We know that now the cars are developed in order to protect people inside and also outside the car. Well, everything are designed using functional safety. Also, functional safety is used for aerospace, why not? For nuclear plant, for machinery. We have some different norm and standard related to functional safety, each one for each different application. Today, I would like to speak with you about the process industry. We know process industry, I think that all of you are working in the process industry, more or less. Process industry is the big group, including, for example, oil and gas, polyolefin, petrochemical, chemical, a lot of meaning also. And we have a standard of reference for functional safety for process industry, that is ISC 61511. Too often we speak about SIL level, safety integrity level only. This is related functional safety for process industry, but is not only the term for functional safety. SIL, I will explain, I try to explain in detail what is safety integrity level meaning. And then for sure, maybe, probably, you have different concept in your mind related to safety integrity level. Yes, because normally safety integrity level is associated to device, but it's not like that. We will see that safety integrity level is one term of functional safety and is addressed to the safety instrumented function. What is safety instrumented function? I will explain during this presentation. And I'm a functional safety expert. From last year, from 2020, I'm also the only trainer for UL, related functional safety for process industry. And I got the certification as expert, certified functional safety expert of the ISE 61511. I'm also the teacher for UL, for Certified Functional Safety Professional Certification. And I will explain at the end of this presentation why you have to get certification for functional safety. Let me introduce quickly myself. I'm a functional safety expert. I already told you with the certification CFA 6 by UL. I have more than 15 years of experience in functional safety. I can train a lot of people, companies in Italian and English. And also I'm a leader of the heads-up meeting and also seal allocation meeting. I'm, in addition, assessor for the functional safety assessment. What is functional safety assessment? Assessment is the only way in order to judge and demonstrate the compliance of a 61511 standard. Unfortunately, we cannot speak about the certification 61511 because it's very, very complicated. And then I'm also expert in order to verify through some calculation, that is probabilistic calculation, the SIL level for the safety instrumented function. And I'm obviously experienced in order to design, realize, install all passage for the safety instrumented system. With my company, we can develop everything related to functional safety 61511, including courses in order to train the company, course for the certification, and consulting services for complete management of functional safety. The management is very, very important in the functional safety. You cannot perform any project without a correct management of that. Management is required by standard and also is required by a company, for example, end user. Management means an additional parallel way for the safety instrumented system design. That is very, very important. Then I did a lot of training in the world in the last 3 years, starting from the beginning of 2020. I did more than 500 hours, and unfortunately, due to COVID, I cannot perform training in presence. This is my last training in presence, and it was in Istanbul, at the presence of many managers and also technicians. So from the COVID, from March of last year, I started to provide webinars, free and also complete training course for functional safety. And so now I have a big number, 42 webinars with more than 300 participants. I think today we reach 400 for sure. And this is very, very pleasure for me. The service for functional safety that we can provide by my company, you can see that are everything included in the standard 61511. So we will speak during this training, this webinar about HAZOP, and I suppose the HAZOP is common for all of you. So HAZOP is the risk and evaluation of hazard for the project. SIL allocation is an additional step for functional safety, including seal verification, safety requirement specification, and this is very important for company right now, that is demonstration of compliance of 61511 standard. To perform a functional safety assessment is required competent and expert person, and also this person should be external of the project in order to avoid any misunderstanding of disalignment between company and also the assessor. And an additional important thing for functional safety is what is called the safety instrument system validation. I know that probably right now you have some confusion about safety instrument system, safety instrument and function. My tentative this evening is to clear most of this terminology in your mind. Because to start to speak about functional safety, you have to think in a correct way about some terminology that are very, very important. These are some my principal customers in Italy and abroad related functional safety. Some of these are for training. The other thing are other companies are for services. But anyway, all of this company have one point in common. All of this company are coming from the process industry. So, for example, we have this company is power, Tecnimont is for the polyolefin and also HDPE, LDPE, Soccer for oil and gas, and so on. So, for all of this EPC contractor or end user, the ISC 61511 standard should be adopted. Yes, because we are speaking about the process industry. The meaning of process industry is very simple, because we can speak about one industry that start from the raw material, and due to some transformation that could be mechanical, chemical, or whatever you want, we reach the final product. So in the process industry, we can find a lot of fields such as oil and gas, refinery, food and beverage, wood, rubber, a lot of things, a lot of field of process of production. So in all of this, you can apply the functional safety according to the 6151 standard. I realized for you one survey. This survey is just to have an idea of your capability related to functional safety. It's just for me, just one survey, are only 4 questions that now we show. Please answer in 1 minute, and we can analyze the result of this survey. I think, please give me your feedback. You can see this. Yes. There is no votation like school. It's just a survey. There is no name, nothing. Oh, very good. I'm familiar with 61511 and SEAL. That's fine. Korhan wrote me none of the above. CD. CD means the 3 and 4. Yes, I wait, no problem. No problem. I'm waiting for at least a 50% of votation. We are around 30%. Will you talk about EMC? No. EMC is not part of functional safety directly. Let me say that electromagnetic compatibility is one part around the functional safety. It's required, but is not as a recommendation for functional safety. C-level safety of device instruments. We'll see. Okay, I think we can close this survey. Please don't share the correct answer. It's like a school. Is that different between the function safety? Yeah, sure. I will explain at the end of a presentation where I will introduce the UL certification. and there are many differences between expert, engineer, or professional as a UL certification. Okay, no problem. So we can close this survey. I share the result. I think that all of you can see the result of a survey. We can analyze the result. The first question, do you know IEC 61511 functional safety? Result is that only 5%, but this is related only, I think, 48 people that answered, and then only 5% says yes completely. Completely means that you know everything about functional safety from the starting point to the end point, that is decommissioning of the safety instrument system. I don't know about IEC 61511 meaning. Is I think a big number, big percentage of the people, the answers. Then the second point, do you know the meaning of SIL level? SIL means safety integrity level. The first answer was the C level is the degree of reliability of the device. The second is the SIL level is the degree of reliability of the safety loop. And the third was the C level is the degree of reliability of the safety PLC. PLC is the programmable logic solver, controller. So the correct answer is the second. We cannot speak about the safety integrity level for device. This is just let me say, bad information from the manufacturer of devices. Safety integrity level is applicable only to the safety loop, where the safety loop is composed by sensor, logic solver, and final elements. The third question was, does your company apply HAZOP type risk assessment studies? I was sure that a good percentage of your company know about HAZOP. HAZOP is the common methodology for the evaluation of risk and stop. But is one point of functional safety, but is just the starting point. But anyway, is a very good point of start. Where the fourth question, does your company apply the methodology to assign the SIL level, for example, LOPA? And then we have I think the yes always, no never. Half and half. That's fine. It's fine for me because we have to apply correctly the methodology of the seal allocation. It's preferred to apply after some, let me say, training, experience with high quality. Unfortunately, a lot of companies using some deviation, some not correct way for SIL allocation. This means to realize what is called a safety instrument system with a low reliability. I'm sorry, but we are speaking about risk reduction. And so safety integrity level allocation is very, very important. Let me see. I would like to continue with the presentation. After that, at the end, I can answer to your question. You can continue to chat. And at the end, I can try to reply to all your questions. Okay. The big question from companies is why should I invest in functional safety? Why? Because we are speaking about risk reduction. In fact, an accident is much more and more expensive of investing in safety. Companies right now, I'm speaking about Italy, but I think also in Turkey, but even if I don't have a good picture of Turkish companies. Anyway, they want to skip some part of functional safety because they want to save some money. But unfortunately, if an accident occurs, this accident can cost 10 times more than an investment of an entire plant. Training like this, but this is very short introduction of functional safety. Anyway, is a way to help companies to become more aware of functional safety. And then some company normally say to me, but I have a lot of experience. Why I have to invest in training? Why I have to invest in functional safety? Or another answer is this plant is very similar to the other plant. So I just copy and paste the plant because in the old plant, no accident occurred. This is a terrible answer because to make this sentence for a risk, for some possibility of risk or accident, make the position of company in a bad quality of project design of the safety instrumented system. So what I'm sure is that we have to apply both standards and experience. Only standards and experience can save the people, save the environment, and also save companies. So we have to apply correctly the standard for functional safety. Unfortunately, there are a lot of companies that still now in 2021 want to skip to mask the face behind of investment of functional safety. But the company have to think that an accident can cost probably too much in comparison of the people killed. So for now, we have to change mind related functional safety, and we have to improve the culture of safety. I love normally to start from the end. What is the meaning start from the end? This is what is called the safety instrument system. Is normally realized in order to prevent any dangerous event for the high peak of pressure. Is what is called high integrity pressure protection system, HIPS. You have to think this package that is located between offshore and onshore, or platform and boat. The scope of this package is to detect, for example, high pressure, so is a dangerous situation, and in case of high pressure, through the logic solver and the logics inside of this logic solver, to close the line using two valves. This is a very good package in order to protect downstream from the high pressure that is generated by upstream. That's okay. We have a lot of vendors of this system, but the question are, why in this system, in the HIPS, we have to install 3 sensors that are pressure sensors instead of 1, or instead of 2, instead of 4? Why normally is used 3 sensor? Why we have to install a logic solver? And then why we have to install 2 valves and not 3 or 1? The final question is this system designed for safety or for the process control? There are good questions. Everything is designed using the functional safety IEC 61511 standard. Is the only way in order to justify why we have to use 3 sensors instead of 1, instead of 2, instead of 4. 2 valves, but in the market there are a lot of valves, very reliable. But I would like to be sure about the closure of line. So, for my experience, I install 2 valves because 2 is better than 1. This is not a justification. We need to prove and to demonstrate why we have to install 2 valves instead of 1. 2 valves are very expensive instead of 1. Keep in mind that normally this package is installed in the big pipeline, like 40 inches, and so the valves are very, very expensive. I'm not speaking only for the cost of the valve, but we are speaking about also the maintenance, installation, everything addressed to this package. Only with the functional safety applied in the correct way, we can demonstrate and we can realize in the scientific method this package as a HIPS. I can say you that I can tell you that three transmitter, pressure transmitter, are lower of reliability instead of two. But three transmitter are more available than two. But that's a consideration that we have to do only with some methodology, not only by experience. Okay, functional safety can give you the help in order to drive the safety instrument system like that in a correct design way. What is safety? Safety is the freedom for unacceptable risks, where the risk is the probability of damage combined with the severity of damage. Risk means frequency per magnitude. Frequency is how often we have dangerous situation during the year. Magnitude is the consequence, but magnitude is not the consequence only for health, but is the consequence for the people, for the environment, and also for the economic point of view. So our scope, our target is to reduce the risk as much as possible. But before to reduce the risk, we need to know the frequency and the magnitude. Right now we are speaking about, for example, what is the risk of COVID virus. So we can apply this formula also for COVID. Frequency means how often the people are infected during the day or week. Magnitude means how many people are infected or how many people are killed by virus. Okay, so this is the risk. Normally, that all the scientists took in order to study the curve of risk for virus. Anyway, in other words, safety is the avoiding the damage, where the damage is defined as physical injury or damage to people, health, or damage to property or the environment. There are many differences between risk for people, for environment, and so for the industrial. Italian Civil Protection Department define the risk, industrial risk, as possibility of damage for people, environment, where is installed a chemical company. Okay, so that means that all our industrial plant can put some risks for people and also for the environment. So we can enter now in some technical part. We have to define the target of the functional safety. Safety system. We know the safety system is a big family or group where we can include a lot of components that we know and normally we use in our industrial plant. So we can find the safety PLC, pressure safety valve, and the raptor disk, and the safety relay, and other thing. Okay, this is just for example. The important thing for all of that is that are not part of the process control system. So we have to divide, to make a separation between process control system and safety system. It should be independent between process control system and safety system. Inside of the family of safety system, we can define the safety instrumented system. As per standard 61511, and also before there is a standard for functional safety is 61508, safety instrumented system is composed by a combination of sensors, logic solvers, and final elements. This is the definition of safety instrumented system. If you don't have, for example, logic solver, you cannot speak about safety safety instrumented system. Will be a different safety system, but not safety instrumented system. Safety instrumented system is the target of the functional safety 61511. So we have to realize, to install, to make in operation a correct safety instrumented system. Correct means is depending by risk. The good question should be, I need is always required safety instrumented system? The answer is no. We have to develop the functional safety in order to justify the requisition of the safety instrumented system. The safety instrumented system corresponds to the set of all safety loops of the plant. And the important thing is the safety instrumented system must be an independent system of process control, of fire and gas system, of a lot of system inside of plant. Safety instrumented system is what is called the prevention layer, while fire and gas is a mitigation layer. Please don't make a confusion between safety instrumented system and the fire and gas system. Are completely different system. In order to define better our safety instrumented system in plant, we can see by the sky, okay? So we can define that everything is collected to the PLC, safety PLC, is part of safety instrumented system. So at this point, we can find a valve and also pump or some machinery. But pump are not safety device itself. Power disconnector of pump should be safety device. Okay, so pump is a process device, whatever you want, but is not itself a safety device. We have, for emergency, probably to disconnect pump from the power in order to stop the pump. This is one of the most common used strategy for the emergency. One other term is the BPCS. BPCS terminology is a basic process control system and is dedicated to the manufacturer, not the safety. Is addressed only to production. Inside of BPCS, you can find, for example, distributed control system, the PAC for production, including all field devices, but is addressed only for the production, not for safety. While safety instrument system is only for the safety. Then, inside of safety instrument system, as I told you before, safety instrument system is the collection of all safety loops. These safety loops are called normally safety instrument function that corresponds to a SIS channel designed to protect the process from dangerous scenario. Dangerous scenario, for example, is the high pressure, high level, low level. This is the dangerous scenario. One step after the dangerous scenario is the dangerous event. For example, explosion of the tank due to high pressure. SIS is therefore composed of all the planned SIFs. And the very important thing is the SIF refers to a single function, like high or low pressure. We can use safety, for example, one single sensor, one single transmitter for different functions. For example, SIF1, this in red color, is related to pressure transmitter, PT. Let me change the pointer. Oh my God, I'm sorry. Okay. This is a PT transmitter. Very well. Maybe this PT pressure transmitter can detect through logic solver two different dangerous scenarios, such as pressure low and the pressure high. Two different value of pressure, what is defined normally as a trip value. For sure, there's two different scenarios, are two different SIF. One SIF, the first one, is applied for high pressure. The second one is for low pressure. And then, what about the final elements? The final elements are normally used in order to drive the process in a safety state. And we have to define, in order to avoid a dangerous event, maybe for the SIF1, we have just to stop this pump. And vice versa, maybe for the low pressure, we have to close these two valves and also to stop the same pumps. We have to establish during the SIL allocation what is the scope of the safety instrument and function, and also to define very well sensors, logic solver, and the final element used only for avoid all dangerous event. This is the first and very important thing for design of the safety instrument and function. I would like just to show you a real example. This is a big plant of crude oil transportation by different tanks. And when I arrived and I got this project, no one thought about the safety instrument system. So this part that normally are safety instrument and function were not there. This P&ID was white for the safety instrument system. So during the HAZOP, that is the risk assessment, we define due to the causes, the tank gauging system failure. Tank gauging system is let me check. This part is a level detection. In case of failure of this level transmitter, we have two different dangerous scenarios or event. The first, fuel release from the tank in case of high level. In case of low level, we can have the tank emptying and cavitation of the transfer pump. So two dangerous events by the same failures. The failure is the level transmitter 0012. At this point, after the HAZOP, we established that the risk of this hazardous scenario was very high. And during the SIL allocation, we established the requirement of two different SIFs. The first one was for high level in order to protect by release of the crude oil, closing the valve of the inlet crude oil of tank. The second one was in order to protect by low level. And they were two different functions from the same transmitter. The second one, that it is low level, goes to trip to stop the transfer pump. Here is showed only one pump. There were 5 different pumps. Anyway, they stop the trip signal from the safety PSC goes to all 5 pumps. In addition, to be sure to trip this pump by cavitation, we include also an additional function with additional pressure transmitter. In case of low pressure, through the emergency shutdown system, we're going to disconnect the pump from the power, and so to trip the pump. The same activation, so disconnection of the power, feed power of the pump, in case of high pressure. Why? Because the problem was this manual valve. In case of mistake by operator close this valve, the pump should be broken due to the high pressure. So, during the SIL allocation, we define to install a new function in order to protect the pump from the high pressure. These are just an example of the functions that normally is designed by safety instrumented system design. Very well. But now we have to define what could be the reliability of my safety instrumented function. The help from the standard 61508, that is the first standard for functional safety, is what is called safety integrity level, SIL. Is defined as a level of risk reduction provided by safety instrumented function. By safety instrumented function, not by devices. In simple terms, safety integrity level is the performance measurement required of a safety instrumented function. Checking the table from the 61508, we can see that we have 4 different levels of SIL, from lower to the higher, or the highest, from SIL 1 to SIL 4. For each level of SIL, we have direct correspondence of the range of risk reduction factor. So means how many risks I have to reduce in order to avoid any consequence for the people, for the environment, and for the economic point of view. SIL 1 is lower range of risk reduction factor instead of SIL 4, where is required a very high risk reduction. And then the information that we arrive from SIL is not only the risk reduction factor. We have also what is called probability failure of demand for the safety instrumented function. This is the probability of failure when is required the activation of the safety instrumented function. Is a probabilistic number that is linked to the reliability of the safety instrumented function. And then, during the SIL allocation, we have to establish, first of all, what is called the minimum acceptable risk, is what is called tolerable risk. This is very easy because we have a lot of literature of that. We know for the oil and gas, for the process industry, what is the range of tolerability of the risks. Then, the target now is, first of all, to define possibility of a dangerous event. Then we have to estimate, to make, to give a number of this risk. And for example, for the high pressure of tank, we define the risk is 1,500. The scope, the target now is to move forward of this number to this tolerable zone. This is the target for functional safety. But anyway, we have to follow the life cycle of standard in order to reduce this risk. In case of, for example, 1,500, we establish the seal level, that is seal 3, and then there are many requirements inside of standard for redundancy, for architecture, for capability, for a lot of things. So the output of our SIL allocation is, first of all, to define the seal level as a risk reduction to reduce and to move to the tolerable zone. Then, with this information, I have to design the safety instrument and function in order to move from 1,500 to 0, for example. But we cannot speak about risk 0. Attention, it makes no sense to talk about the sea level of device. And the second thing is there is no SIS certification. The certification that we receive from the manufacturer are the compliance of the 61508. So the certification is the 61508 compliance. It's not SIS certification. And normally in the certification there is the seal level, some seal level of device. But it's not the seal level of device. It's the maximum availability of the seal level where we can install device. So, for example, this power drive system is possible to install in a function that should respect the seal 3 capability or seal 3 requirements. This means that it is not the seal level of device. We are speaking again about the seal level for function. We can install this device in a function that have to answer of seal 3 requirement. This is the difference between the seal level that normally we use seal level for device. No, we have to speak about seal level for function only. Very well. Now we can define the functional safety definition by 61511 standard. Definition is the functional safety is the part of the overall safety related to process and the BPCS, which depends on the correct functioning of the SIS and on the other level of protection. More simply, functional safety is the reduction of risk provided by safety instrument and function, designed and installed to guide or to drive the process in a safe state in the event of a dangerous situation. It's very clear, this definition. We have to, first of all, evaluate what could happen in my plant. If, for example, we have a failure of the BPCS, we have to install a safety instrument system in order to drive the process in a safety state before of the dangerous event. The safe state avoids consequences that can be described as injury or death of human beings, release into the environment, or loss of the equipment or production. Be careful because we cannot speak about 100% of functional safety, because this means to reduce the risk of zero. And this is not possible, since the devices installed in the safety instrument system are real, and real instrument can fail. The question is it always necessary to install SIFs and therefore safety instrument system? No. Maybe it's not required, because maybe I have already installed or designed a lot of safety devices, and the safety device reduce the risk to tolerable zone. So why I have to install safety instrument function just to make a complication of my life? Maybe it's not required, because it is sufficient to have a precious safety valve. Why I have to install a lot of hardware, to spend a lot of money, and maybe the safety instrument function installed where is not required make some problem of the process. We have two different standards for safety, functional safety for the process industry. The first one is a 61508. Is the standard addressed to the manufacturers and supplier of devices. The second standard is the 61511 standard, and is related to designers and safety safety instrument system integrators and end user of the process plant. Anyway, if you are designers, for example, you have to realize SIS using components compliance of the 61508. This is the relationship between 61508 and 61511. How is composed 61511? I'm showing you the life cycle of standard. We have to follow from the top to the bottom, from the hazard and risk assessment to the decommissioning of the safety instrument system. We can define three different zones of the life cycle. The first zone is the risk analysis and the safety instrument and function definitions. The second zone is the safety instrument system design, installation, and validation. The third is the operation and maintenance of the SIS. Life cycle is related only to SIS, not to the process plant. And then we have all the steps to follow in order to make a compliance of the standards. And then we have to manage also the life cycle using, for example, a functional safety management plan, and somebody from the extern of the project design should make the assessment of the functional safety during some stages of the life cycle. The stages should be stage 1, stage 2, stage 3, stage 4. I'm just summarize what is normally provided during the functional safety design. So we can speak about risk assessment and consequence, that is HAZOP. Then we have to evaluate the safety instrument and function, assign the C level to each SIF, develop the safety requirement specification of each SIF. This is particular. It's a requirement of is a technical requirement of each safety instrument and function. And then we have also to realize the FAT, installation, commissioning, and so on. Everything is related to the safety instrument system only. Then, just to summarize the chain of the event occurring during a dangerous situation, this is an example of the tank with some water, raw water, for example, is a utility. We have to transfer the water from downstream to from the upstream to downstream using the pump P0101. If we are going to a correct way, the level inside of the tank will be around this value, is the design value. But due to, for example, closure of this valve, that is control valve of level, the level decrease. So our scenario meet the failure of the control loop and meet the pre-alarm that is here. Is normally what is inside of a control room. Operator can see that something goes to a dangerous situation. And if the operator have time, maybe can resolve the situation. If not, we reach what is called the hazardous situation. So means probably this level of water, low level. In case of existing safety instrument and function, we can close the valve and also stop the pump in order to protect by cavitation. If not, because maybe we have a failure inside of safety instrument and function, so we reach for sure the consequence. Consequence that in this case is the pump replacement due to failure or damage inside of pump itself by cavitation. So in this case, during the HAZOP, we identify initiator, that is control valve closed due to BPCS failure. The dangerous scenario is the empty tank with the cavitation on the pump suction line. And the consequence, we have only economic consequence. Pump breakage, and in the worst case, it needs to replace the pump. We identify a single function. The function will be level transmitter, and with low level through the safety PLC, stop the pump. This is the correct safety instrumented function in order to protect the pump of cavitation. So the first thing is to realize what is called the hazard and risk assessment. We have to check all the process line and to define some deviation from the design. In case of this deviation, to establish what could be the consequence, safeguard, and if is required, any recommendation. In my case, due to no flow from the line, due to the causes will be the valve closure. So here will be LV0101 close. We, in absence of any safeguards, we meet the consequence that will be only economic consequence, and in the worst case, we have to replace this pump. Safeguards in the hazard, we have to make a list of all safeguards present. And in this case, the safeguards will be the low alarm for the operator console. The other safeguard is already installed the safety instrumented function in order to protect the pump. If we have any recommendation, normally we can write inside of the HAZOP according by decision of the HAZOP team. Recommendation should be to check better, for example, to evaluation to install a new SIF. The second step for the functional safety, once the safety instrumented function has been identified, it is required to assign the C level for each SIFs. The common methodology used are two. One is called the risk graph, where the output from the risk graph is the C level, so C1, C2, C3, C4. And the second one methodology is the LOPA, Layer of Protection Analysis. And with the LOPA, we have the output, both C level and exact number of risk reduction factor to be respected. So the first one is qualitative methodology, and the second one is qualitative and quantitative methodology. Normally, we can identify the C level for hazardous situation. In case we identify an hazard situation and there is no safety instrumented function, we proceed with SIL allocation. In case of C level will be one or more than one, we need to install a new function like that. This real example was without any safety instrumented function. We identify the risk of the overfilling of the XN storage in the tank and the explosion of the tank by SIL2 level, but no SIF was installed. So, in that case, after the SIL allocation, we design a new SIF, SIL2 level, like that, level transmitter and closure of valve. This is another possibility. The step 3 of the functional safety is safety requirement specification. Is a normative, so means in order to be compliant of this functional safety, you have to provide a safety requirement specification. The standard 61511 reports to show 29 hardware requirements and 14 software requirements for each SIF. You should prepare one single document, new document for the SIF, or collection of the existing specification already prepared, but with the identification of each hardware or software requirements. The safety requirement specification is the master document of the safety instrumented system. If you modify any specification, you have to modify inside of a safety requirement specification. There is no closure of the safety requirement specification. At the end of your design, you have to forward the safety requirement specification to end user. End user have to maintain updated the safety requirement specification in case of modification of safety instrumented system. So when we describe all the requirements by functional safety, we have to choose in the market devices. It should be all devices according to the standard 61508, and then using the failure rates from the vendor, the manufacturer of devices, I can perform what is called the safety integrity level verification. Using the 3-barrier method that is normally is common used in the world. 3-barrier means 3 different safety integrity level. The first one is the systematic capability. Is the capability by instruments in order to meet the requirement of the seal. The second one is the constraints of the architectural, so means we need to add additional instruments in redundancy. And the third one is the PFD calculation. Remember that from here we establish the C level and then the PFD by table. Here we have to verify using the failure rates from manufacturer that we respect the C level by the seal allocation meeting. When everything is okay, so means all the sea level meets the sea level required, we can go on through the realization of the safety instrument function, test, installation, commissioning, and validation. That is the step 5. Since validation is the test on site of the performance of the safety instrument function. You need some expertise to realize the safety instrument system validation, because it's the last point. After that, you make in operation the safety instrument system, but you have to be sure to respect the seal level by seal allocation, the safety requirement specification, and also the seal verification. Then I'm going to the end of this webinar. During the operation of the safety instrument system, somebody have to check the performance of the safety instrument function after, for example, 1 year, 2 years, 5 years. Because you have to think that the safety instrument function normally remain in one position for a lot of time. You have to be sure that in case of intervention of a SIF, this SIF activate correctly and then drive the process in a safe state. You need to make some test of function from the sensor to the final elements. For example, proof test of the valve means to close completely the valve and to reopen the valve. This is the test in order to establish that performance of the valve still remain for this safety instrument function. You need to prepare a procedure for that. You need to use the safety manual. The last point that I would like to speak about is the functional safety assessment. I already told you that there is no certification 61511 because it's very, very complicated to certify by certification body one safety instrument and function. The standard required to make what is called by the functional safety assessment by functional safety assessor, where during some different stages, stage 1, so means after the safety requirement specification, stage 2 means after seal verification, stage 3 means after commissioning SIS validation, and then stage 4, stage 5. It is important to note that assessor must be an independent person and competent person of the functional safety. The assessment of functional safety is not technical assessment. The competent person make a judgment of the quality of the functional safety. Normally, companies call me in order to evaluate the functional safety, and I make a collection of all documents such as heads-up report, seal allocation report, safety requirement specification, and I make some comparison between them. The stage 3 is very, very particular because normally I'm going to the company on site in order to check also the existing of the safety instrument and function on site. This is my last slide of the functional safety introduction. And now I would like just to speak about the certification of the people. Certification is external word from the standard. The standard means to perform functional safety need competent team or competent person. The competency is acquired during training and also experience. But anyway, with UL, where I'm developer of functional safety training for 61511 and also teacher of that, you can acquire, you can reach the competency of the functional safety, performing 3 days of training, and then to get a final exam by UL itself. Remember that UL is, I think, the biggest company of the certification in the world. We fix a different training course by different location. The first one will be on 12 April for MEA location. The second one is for South America. The third is for the UK. And the fourth for right now is for the Italy, in Italian language. Why get a certification? Because company, in order to have different projects, need to show the competency of the team. So companies need to have people inside with the certification of the functional safety 61511. At the end, you will be able to manage the functional safety, to realize seal verification, and to design the safety instrument system as required by risk reduction. The target audience for the functional safety certification is automation, process engineer, health HSC, all people inside of the team for the project or also for the end user. It should be your question in chat. Let me see. Okay, the first question is by Ruhi. Is there a difference between a functional safety expert and functional safety engineer? Absolutely yes. To be functional safety expert, there are some requirements by certification body, means some years of experience of functional safety. I think is 10 years. And then to realize some specifications, some demonstration, and also to have a particular exam in front of competent expert people like me. For functional safety engineer, is required to have familiarity with the process plant. You can be very young engineer, but anyway, you have to know about the differences between automation for process and automation for safety, for sure. You have to read P&ID, for example, for the process point of view. But anyway, is very, very easy. My training, I love to speak in an easy way and to perform a lot of number of competent people. I have, by Syed, I have seen many industries deploying various seal level like seal 4, and some are up to seal 5. How this is to be adapted? Doesn't exist seal 5. I know. There are some very confusion about seal level. Seal 4 means very high level of risk reduction. Normally, our tentative is to avoid Seal 4 for process industry, because this means to realize two independent safety instrumented system. There is no component or devices for the process industry with the seal capability of Seal 4. Normally, to avoid the Seal 4, we can apply additional safety layer independent by safety instrumented system. And then maybe we can provide the safety instrumented function by Seal 3. There are a lot of ways in order to avoid the Seal 4, but anyway, Seal 4 is terrible for the process industry. By Corhan, SIS uses its own PLC and not the automation own PLC, right? If I understood well, we need to separate PLC for the process and for safety. This is mandatory for functional safety. We have to avoid any miscellaneous thing between safety and the process part. What standard says about interlock? Whether interlock are allowed to configure in DCS or only in ESD? Interlocks, there is no mentioning about the standard for interlock. Interlock is just our definition of organization from input, output, and the logic port inside. Anyway, SIFs should be represented by interlock. But an interlock is just organization of what is called the application program inside of logic solver. So there is no importance about the interlock. Anyway, in order to activate the safety instrumented function, we have to respect some organization by interlock or by different name that you want. Whether single transmitter shall be used for control as well interlock. Interlock means ESD safety. No, you cannot. You cannot mix safety device and control device. You have to think that if device fail, you can lose control and safety, both. So standard is clear for this point. You have to make independency as much as possible between control and safety. You cannot, let me say, mix process and safety just for save money. No, absolutely. You are outside of standard. Periodic testing will vary based on sea level? No. Sea level is the performance. Periodic test means how long you have to test? Yes. So means for SEAL 3 maybe is required or is necessary to test each year. For SEAL 1 maybe 5 years. In this term, yes. But as a procedure of test by SEAL 3 and SEAL 1, there is no differences. Are the hearts of this method using only in this standard? No, absolutely. There are many standards for safety where HAZOP is used. HAZOP is born for the military field, not for the process industry. HAZOP you can use it also for machinery. Also for the medical device, why not? For the train, for the automotive, why not? Can we use in the FMEA? Yes, sure. You can use different methodology in order to define the hazard situation, consequence, and so. And also the FTA. FTA was I don't know what is happening now. Okay, the FTA is very interesting point because with FTA the output is also the frequency, for example, for a year of this dangerous scenario. And then for functional safety, is it mandatory to be certified? No, it's mandatory to be competent. But how to demonstrate your competency for the customers? So a correct way is to be certified by competent organization body like UL. My company that is called Mind is not certification body, okay? So I use the UL in order to certify people and myself as a competent person. Is online exam expensive? The training itself is expensive. But you have to compare of the future consulence in order to reach the functional safety. The companies that have inside some people certified can save money for the future, save money for the budget plan, and also from the external people as competent. We thank the Ankara branch of the chamber for your participation on the seminar and Davide's great presentation. Thank you very much. I think there is no how producer test a device failing 1 in million in real. I don't understand the question. Sorry. And we have additional question. What is the requirement for functional safety according to 6151 standard? For example, PTV permit to work for brownfield area. There is no requirement for that. Absolutely no. Because functional safety is required for the safety instrument standard. Anyway, I would like to thank you for this opportunity by Chamber of Electrical Engineers of Ankara. If you need any help or question, in the beginning of this chat, you can see all my contact, our personal company's contact by phone, via WhatsApp, Telegram, or LinkedIn. I'm always present on social media, different social media. If you liked this presentation, please comment on LinkedIn this presentation. And so thank you very much. I hope to see you in presence very soon. Means that virus will be skipped. And have a nice night, have a nice evening to you and to your family. Thank you very much. Bye-bye.